In the world of requirements management, collaboration between stakeholders is critical. The IBM solution allows any stakeholder to participate with little to no learning curve by employing web-based SaaS technology. There are no complex desktop clients to install, and anyone can use a web browser. Here we're looking at a module or document of requirements. The IBM solution has a powerful editing environment, including rich text, tables, images, and even sketches can be created right here in the web client. So no more switching to PowerPoint or Visio, and no more copy and paste. One of the basic tenets of good requirements management is granularity. Each requirement in this module is an independent atomic artifact, which has several benefits. Using traditional document editing tools, multi-user collaboration is difficult and impossible to manage. Not so here. With the IBM solution, individual requirements may be locked for editing, so many engineers can work on the same document at the same time. Another important aspect here is reuse. In the IBM solution, reuse is built in. Requirements may be used in any number of other documents or modules, so no more copying and pasting, and all of the overhead that goes with it. Individual requirements can be traced to other artifacts in the system, such as work items or design elements, as we'll see a little bit later. After a document is ready for interested parties to review, stakeholders can discuss and collaborate by commenting directly in the document. Important decisions and discussions are available to the team. No time or effort is wasted by chasing down emails, or making, consolidating and responding to similar comments. Can you see how you could be more productive already? When it becomes time for a more formal review, IBM has you covered. Reviews are built into the solution. Stakeholders can review requirements and provide their feedback in context, using just a web browser. The platform tracks the progress of both the reviewers and the review as a whole, and any comments made are maintained for an audit trail. The results are immediately available, so no more passing around copied documents, waiting for and collating results. Change control is built into the solution. Here, the project lead has imposed change control on this project. Any change has to be made in the context of a change set. This allows the team to manage the impact of changes, as well as ensuring that changes are only made with the appropriate approvals, and that those changes are properly documented. Any changes that are made are automatically captured, and we can view that history, either for a single requirement, or in this case, for the entire module. Here we can see the complete history of this document. When a change was made, who made it, exactly what that change was, and in which change set. All of which helps to demonstrate compliance to industry standards, such as DO 178B and C, ASPICE and ISO 26262, without any manual intervention. At any point in time, a baseline can be created, an immutable version of the state of the requirements at that time. Baselines are all about getting to a common base agreement between stakeholders, setting the right expectations, allowing us to manage the scope of the requirements, and also paving the way to setting schedules. In the IBM solution, you can even compare baselines, either to other baselines or to the current state of work. Traceability is a key aspect of requirements management. Traceability allows business leaders, engineers and planners to answer key questions about the products or systems they're delivering. Does the product meet all of its requirements, and no more than that? Have all of the requirements been sufficiently tested? Without effective traceability, fully understanding the impact of change is a costly exercise, and one that can have huge ramifications if it's not done correctly. Traceability also encourages collaboration, allowing testers to easily see which requirements they're testing against. For example, breaks down the traditional siloed approach to systems engineering and product development. Traditionally, this traceability was maintained in separate documents, such as spreadsheets, a manual process prone to error, very costly to maintain, and outdated as soon as the author clicks save. Here, engineers can link as they think, not only between different levels of requirements, such as stakeholder to system, as we're seeing here, but also between requirements and the rest of the life cycle. Here, for example, engineers can link to and even view elements from the designs that elaborate or implement these requirements. Industry standards often mandate a high level of traceability. IBM Engineering Requirements Management removes the manual, time-consuming effort associated with demonstrating compliance to standards like those I mentioned earlier. Hovering over a linked artifact, such as this sequence diagram, shows us the details of that artifact in a rich hover, a common capability across the IBM solution, and a huge time saver. This view shows the linked test data. We can see whether a linked test case has passed, failed, or has never been run. We can also see link validity. Whenever two artifacts, such as a requirement and a test case, are linked, if one of those artifacts changes, then the connection between them becomes suspect. Is the test case still valid if the requirement changes? The IBM solution automatically highlights when this happens, so making that assessment is much easier. What about impact of change? How do we assess the impact across the lifecycle when a requirement changes? In the Link Explorer, traceability may be explored graphically, and this view may also be used for rich hover and also for navigation, making impact analysis much easier. Writing good quality requirements is no easy task. Requirements documents often end up undergoing multiple peer reviews. And when those requirements are poorly written, those reviews often waste time on how a requirement is written rather than its meaning. Often the best people to define requirements are the users, who may not be experienced in writing requirements at all. Poorly written requirements introduce errors, which can often propagate through the design, implementation and testing phases, incurring exponentially increasing costs the further they go. IBM introduced Requirements Quality Assistant with the power of Watson Artificial Intelligence to help you improve the quality of requirements as they're written, reducing ambiguous, incomplete and poorly structured requirements. That allows any peer review to focus on what's important. Is the requirement necessary and is it correct? Here, for example, Watson is advising that 2 of our requirements are not quite up to scratch. This one is a compound requirement, 2 requirements combined into a single one, which is difficult to test. Now that's an easy mistake to make even for experienced requirement writers. This one contains terms that may be vague or imprecise, in this case the word clear. The phrase "in a clear manner" is subjective, ambiguous and difficult to test. Now note that the requirement above this one also contains the word clear, but in that context it's not ambiguous at all. This quality checking goes beyond simple textual analysis, such as keyword searches, and can instead understand context, meaning and intent.